The Global Carbon Budget is a project of the Global Carbon Project, which is a research project of Future Earth. And it's in partnership with the WCRP, the World Climate Research Programme. So the Global Carbon Budget 2019 is the 14th edition of the annual update since 2006. It's produced by 76 scientists from 57 research institutions working under the umbrella of the Global Carbon Project. So here to present the 2019 update is Glen, who is a research director at the Cicero Centre for International Climate Research in Norway. He works on past, current and future trends in energy consumption and greenhouse gas emissions, and he's been involved in the carbon budget work for about 10 years. Also on the panel here to answer questions is Matt Jones, who's a senior research associate at the Tyndall Centre for Climate Change Research at the University of East Anglia in the UK. And he has a particular interest in the role of landscape fires in the global carbon cycle. Thank you very much, Glen.
Okay, thank you, and good morning, everybody. Welcome. So as some of you may have noticed, we had the Global Carbon Budget come out last night with the latest results, and I'll just go through the key points, and then we'll spend most of the time for questions. So just summarising, Sophie mentioned this is quite a big effort, 76 people involved. When you sort of look at the interactions in different research communities, there's probably hundreds of people involved. This year we have a main paper in the centre there which has all the data and description of the data. 2 papers you see on the left describing some of the results. We also have a web page. Just Google Global Carbon Budget, you'll find it, which links to all these things, and there's a Global Carbon Atlas which has all the results. You can view them and interact with them. So what is the Global Carbon Budget? It's essentially an accounting of the sources and sinks of carbon in the atmosphere. So we're putting carbon in the atmosphere in 2 main ways. Most of it from burning fossil fuels. That's the grey part in this figure. Another part from deforestation, basically chopping down forests, and that's the sort of the browny colour in the figure. But of the carbon we put into the atmosphere, a part of it is taken up by the land, and a part of it is taken up by the ocean. So the planet does a very good job in cleaning up half our mess, and only about half the emissions that go into the atmosphere remain. I'm going to mainly focus on the fossil emissions component, but I will touch a little bit on some of the other aspects. So the headline result from our report that came out last night is emissions went up a sort of a low 0.6% in the last year, during this year. This is an estimate based mainly on monthly data. It has an uncertainty range. Emissions could have gone down. There's a small chance emissions may have gone down, and there's also a chance emissions may be higher, but our sort of central estimate is around about that 0.6%. What does 0.6% mean? It's sort of in line with the growth rate in the last decade, about 0.9% per year. You know, every year emissions go up and down a little bit because of economic activity, maybe goes up and down, maybe there's a trade war, maybe there's some weather events around the world. There's also climate policy and energy policy. So I'd say 0.6% is very much within the trend line of what we're expecting. It's lower than the growth rate during the 2000s, which was about 3% per year, but still emissions are rising, 4% higher than when the Paris Agreement was adopted in 2015. And for those of you that have seen the emissions gap reports, there needs to be basically a 50% reduction in emissions in the next decade, something like 7% per year decline in emissions. So 0.6%, lower growth rate than usual, but still a long way from where we need to be going. What's driving those changes? There's a few interesting things here. This figure shows coal, oil, gas. Coal is the brown figure, the brown line at the top of the figure, and you can see coal may actually have peaked. I think it's a little bit too early to say that for sure, but coal is having some ups and downs in the last few years, and this year we expect coal to go down about 0.9%. Oil, the black line in this figure, is growing quite strongly, up another 0.9% this year, which is more or less growing on trend. A lot of demand for oil in the developing world. Also demand in the developed world, Europe, US is also quite persistent for oil. Gas, I think, is a surprise. This is the blue in the figure. Gas is growing strongly. It looks slow. We tend to forget about gas, but it's actually growing the fastest in relative terms and absolute terms. And about half the growth in global emissions in the last few years is coming from gas. So we really have to keep our eyes on natural gas and not just focus on coal and oil. At the country level, this shows the top 4 emitters in terms of total emissions: China, US, EU and India. Other countries, the rest of the world, is shown in the black there. So this 0.6% in global emissions is broken down into these regions. China has grown about 2.6%, which is a little bit similar to the last few years. China has a constant tussle between a declining GDP growth rate as the economy restructures and the Chinese government injecting investment, particularly in the construction sector, infrastructure sector, which is pushing emissions up. The US and the EU both went down we expect both the US and the EU to go down 1.7% this year, and both due to big declines in coal, both 10%, which is coincidental, the 1.7 and the 10% both being equal in the US and the EU. In the EU, the emissions trading system has quite a high carbon price at the moment. This has led to a big shift away from coal production in power generation, but industrial production or industrial uses of coal is not going down as fast, and so we only expect a drop of about 10% in total in the EU for coal. Oil and gas growing. US continuing this shift from coal to natural gas, solar and wind that we've seen in the last few years. India is a real surprise this year. Emissions have been growing about 5% per year in the last decade in India. This year we're expecting around about 1.8%, which is quite a bit lower. What are the reasons behind that? There's been a pretty slow growth in coal in India. The economy is a little bit weaker, which has made a contribution, but there was also a very big monsoon this year in India, which floods coal mines, makes coal production harder, so coal power electricity generation had a big drop, or not so much growth in India, and there was a very big year for hydropower. So those two factors are playing a big role in India, so this 1.8% increase I don't think is a new trend emerging in India. We'll have to see. The rest of the world growing about 0.5%, primarily due to slightly weaker economic growth. Overall, the economy's grown a little bit weaker this year than last year, about 0.6 percentage points lower, and that plays an effect on these global emissions. This year we also have some sectoral-based results. I'll just touch on these quickly. The green line here shows CO2 emissions from electricity generation and heat production, and together with energy, which is at the bottom of this figure, about 45%, let's say close to half global emissions are coming from those sectors. And you can see a little bit of levelling out. Maybe there's some good news in that we're seeing a slight softening of growth in electricity production from coal, and that may go down in the next years. Industrial production is the next biggest, about 23%. This is including cement. Again, it's levelled off the last few years, which is nice. Transport, this red line here, or pinkish line, is national transport, so within country borders, aviation, land, water transport. That's growing strongly and persistently, developed and developing countries, particularly in developing countries. The bottom of the figure here is international transport, 3.5%, both aviation and maritime, which is growing but from a lower base. And remaining sectors, I won't go into the details, they're remaining relatively flat. There was a lot of news during this year about fires in Amazon in particular, a lot of focus. We do have some preliminary estimates based on fire activity in those deforestation areas, and we do expect an increase in emissions from land use change in 2019, a small increase, but a lot of uncertainty. The trend in the last decade is a slight increase, although there is quite a lot of uncertainty with these estimates. Not so easy estimating emissions from land use change. When you put the two together, this shows fossil emissions in the grey and the uncertainty, and land use change emissions in the brown, also with the uncertainty. So you can see land use change emissions are a much smaller component of the total emissions, about 14% in the last decade. They also have a lot of variability. And adding the emissions together, we get a new record this year in terms of around about 43 billion tonnes emitted in 2019. And this will be the last slide. We put CO2 into the atmosphere. As I've mentioned, a part of that gets cleaned up by the land sink and the ocean sink, and what remains in the atmosphere leads to an increase in atmospheric CO2 concentration, and we can measure this very accurately. We can go out, see how much CO2 in the atmosphere there is, and that has been increasing quite strongly. It's about a 40% increase since pre-industrial times. This year we expect another 2 parts per million increase, taking it up to about 410 parts per million. And this CO2 in the atmosphere is what's causing climate change and the reason why we are here. So I'll finish up there and happy to take questions.
Thank you. We'll take this question here, please.
Thank you very much. We do not see the agriculture and food sector in your results.
Yeah, well, there's another. Well, I'll answer that question. It's pretty quick. Yeah, that's correct. I should have pointed that out. This is focusing only on carbon dioxide emissions. We're not including all greenhouse gases, so we're not showing methane emissions here, nitrous oxide, and so on. And so, therefore, you don't see food. Yeah. So that's a very important point. This is carbon dioxide emissions. Yeah, have a look at the emissions gap report. That'll have some of the data there.
Okay, we take this question now, please.
Oh. Yep, you're on. That's good. You're on.
It's good?
Yep.
Okay. Georg Ehring, German Radio, Deutschlandfunk. I would like to know the industry emissions. It's the industry produces electricity for themselves, they make heating for themselves. Is this in your statistics in electricity or in the industry? What's the exact definition of industry emissions?
Yes, a nice technical question. That's a very good point. So the way these sectors are defined is generally by the main activity. So if the main activity of the company, if you like, business is to produce electricity, it'll be shown in the electricity. If the main activity is industrial production, it'll be included in the industrial production. Although electricity production from what's called auto producers, which electricity production within the industrial sector, then that's actually allocated to electricity. But yeah, we can take that one offline. It's a pretty technical issue. Yeah.
Any further questions? So can you introduce yourself when you ask your question, please? Thanks.
Anja Paumann, German writer. What is meant with bunkers?
Yes. So because of the way rules are defined, in the way emissions are accounted, emissions are allocated to the national territory where the emissions occur. So emissions that occur in international territory are allocated to what's called international bunkers. So basically these are emissions in aviation and maritime transport that occur outside of territories. So crossing oceans, basically. They are sold individually by countries. So for example, Netherlands sells a lot of bunker fuels to ships, although those emissions aren't allocated to the Netherlands, they're allocated to international bunkers.
Thank you. Thank you. We can take another question from you, sir.
Can you make a prediction how the future will be with the trends?
Yeah, so the easiest way to make a prediction is to look at economic growth in the years ahead, which you can get from the International Monetary Fund, and look at how the carbon intensity, the amount of CO2 emitted per unit activity, has changed over time. So the carbon intensity has improved around about 1.9% per year in the last decade, and looking at projections of economic activity, economy growing 3.5%. So based on that sort of calculation, you would expect emissions to grow around about 1.5% per year. This is sort of consistent with the emission pledges that countries have put forward. Maybe it's a little bit higher. The emissions gap report, for example, will show that current policies are a little bit higher than emission pledges, but still the emission pledges do lead to a slight increase in emissions. So we need some more policies just to meet the emission pledges, and then on top of that we need huge amounts of policies to get emissions to peak and decline. I would just add to that that you would expect, or I do expect in the next decade, say, emissions to slow down and eventually peak. More of the question is whether they'll go down, whether the peak will be levelling out, or whether emissions will actually drop. And that's the real big question, is how to get emissions down.
Thank you. There's a question at the back, I think. Thank you. Can you introduce yourself?
Yep. Nick Fitzpatrick from Uppsala University. I realise this is a global carbon budgets, but in Sweden we're trying to translate these carbon budgets down to a regional and local level, and I just wondered what the progression on that front was from your end. Thank you.
Yeah, so the analysis here is based on national level statistics, and when you go into individual countries, and certainly in Sweden, you'll be able to get emissions broken out by the different regions within Sweden. And I guess this is the same for many countries, not all countries, and then from that you can start to build a picture of what's going on in individual regions. Although it's important to note, as you get smaller and smaller with a region, and if you go the ultimate down to your household, for example, most of the emissions will occur outside of the region. And so the smaller and smaller the region gets, the more important it is to consider consumption by consuming products which are produced outside the region. So these carbon footprint type analysis or consumption-based emissions start to become important. I should add, we do have numbers here for consumption-based emissions, carbon footprint, showing basically that developed countries are importing emissions from developing countries. For example, China is producing products which are exported and then consumed in Sweden. Although in the last 10 years, since the global financial crisis, the growth in this trade has generally flattened out. So in most countries, developed countries where emissions are going down, the US, the EU, the consumption-based emissions are also going down.
Matt, do you want to add anything on land use regionally as well, or?
I would just like to add to that there's two EU-funded Horizon 2020 projects that are looking at national level carbon budgets, essentially. And they're called Verify and Che, so I'd check those out.
Thanks. Are there any further questions? Yes, thank you. Oh, we've got two, so we should take them both together. Yeah.
Thank you very much. We observe that the electricity sector emissions are two more than the transport sector emissions. Is not this a lack of coherence of the car industry policies in terms of all electric cars? Thank you very much.
Thank you. And is there a second question? Oh, we'll take this one for now because you haven't got a microphone. Yeah.
Yeah, so I didn't fully get the question, but I think I get where you're heading, so I'll answer broadly and hopefully it zooms in to give the answer you're after. So electricity is primarily coming from coal and a little bit of gas. And in many countries, you are seeing, with the penetration of renewables, growth in coal consumption slowing down a little bit, and hopefully some of the renewables displacing coal. In the transport sector, we see strong growth, and I should say in the electricity generation sector, we also have alternatives. So instead of using coal or natural gas, we have solar, we have wind, they can get into battery storage, we have hydropower, we have nuclear, we have all sorts of different options in the electricity sector. Whereas in transport, it's a lot harder to mitigate sectors. We have electric vehicles which are coming on, which will certainly, or hopefully displace a certain part of the market. When you get into longer distance transport, trucking or aviation or shipping, there's not so many solutions and certainly not obvious solutions. So we need there's some things we can do, but we also need technological advances. So we would expect to see emissions maybe drop off from coal power generation, which would be good news. We're not seeing much of that happening in transport. Electric vehicles penetration is still too low. Although one thing that we need to be careful of, which I think you're indicating, is we have to be careful that we're not shifting emissions from one sector. So if we have very big penetration of electric vehicles in countries where there's a lot of coal power generation and so on, the gains may not be as big. There'll still be gains, environmental gains, climate gains, but they won't be as big as if you in a country with a high penetration of renewables, or if you go to Norway with hydropower. So very important that we have to watch for those trade-offs, and that will vary by country.
Thank you. We'll take the question further back. Yep.
Yes.
Can you introduce yourself?
Okay, I'm Javier from Infonible, a digital newspaper based here in Spain. And sorry for my English, I know it's terrible. I'm going to try my best. I wanted to know, what do you think about natural gas and the electricity generation by this gas natural, because some companies here in Spain used to say that natural gas is a great alternative to coal and all that stuff. So I wanted to know, what do you think? Thank you.
Yeah, so it's a good question, and one where you can get into all sorts of interesting debates. But the way I'd characterise it is, if you're going to produce electricity, you're better to use natural gas than coal, but you're also better to use renewables than natural gas. So natural gas is better than coal. The CO2 emissions are about 40% lower, but that just means that you'll warm the planet slightly slower if you use natural gas instead of coal. So natural gas is certainly not a long-term solution unless you have abatement technologies like carbon capture and storage on the natural gas. There is also methane emissions associated with both coal mining and natural gas, and depending on what time frame you're interested in, depending on how well you are at managing that methane either from the coal or the gas, you can get into situations where the difference between coal and natural gas is not as big. But overall, a shift to natural gas, displacing coal with natural gas, can only be a short-term solution if you want to meet aggressive goals like 1.5 or 2 degree goals. And the more aggressive you want to go, the faster you have to get both coal, oil and gas, actually all three, out of the system.
So I think we might have time for one more question. There's one at the front here. Thank you.
Thank you. I wonder, since you are dealing so much with these figures about reduction, I know that some experts are really favoring nuclear power when that comes to carbon dioxide emissions, and I'm really interested in your vision on this power source.
So looking at the data, nuclear power has made a big difference in some countries. France, for example, many European countries, Sweden and so on, nuclear has played a big role in emission reductions in the last, around the 80s and 90s. So there's something to be learnt by looking into that. At the moment, it looks like nuclear power is more expensive than alternative options. But I tend to think about this, I wouldn't say no to nuclear power, but each country has to do their own assessment based on the risks that they're willing to take, based on the alternatives that they have. Not all countries have the same resources available, the same options in reducing their emissions. Different countries have different ability to work with the grid and so on and so forth. So in my view, you have to consider all options for their merits. All options have advantages and disadvantages, and you have to somehow do a trade-off analysis to determine what's the right electricity mix for your particular country. And if that's nuclear, then that's nuclear.
Okay, I think that concludes the event. I just wanted to ask, would you like to point people to further sources of information if they want to find out more?
Yeah, so the best thing to do, or the easiest thing to do, is just to Google global carbon budget, and you should come to the website in the top right there, and from there there's links to where you'll find the data. All the data is available, downloadable, accessible. There's also the carbon atlas on the bottom right there. Search global carbon atlas, it should come up. You can plot the figures by country, compare countries, per capita emissions. And these papers also have, which you can link from these web pages, have a lot more details if you're interested in the details. There's also a website that you can go to, which should be linked to from this page, where you can download a PowerPoint presentation. There's 50 or 100 slides in that PowerPoint presentation. You're free to use it, and we encourage you to use it. Go out and use it. And all the data and the figures can be downloaded in different formats. If you want a PDF, PNG file, or the data and make your own figure, then we encourage you, and go out and use it. Thank you.
Thanks very much. Thanks everyone.
Thanks.